He was a little too close to the mic, so if you want to hang back.
Hang back a little. Yeah, I think that should be enough. Or that was enough. Let's see if that was working earlier.
Oh, you tested earlier?
There, all right, now we're up. It worked that time. All right, I think we're ready.
Yes, we're ready for you. And so with that, we will now hear from Paul Peterson from Intel.
All right, good morning. I've been working in the Developer Products Division at Intel for about 20 years working on high-performance computing. And typically that means C and Fortran and C++. But about 5 years ago, we started realizing people were using productivity languages to do high-performance computing. And we said, this is rather strange. Why would anyone want to do that? But people wanted to do it. And then we started to learn more about Julia and said, well, maybe this is actually a good idea because Julia combines high-performance computing with productivity. But we looked a little bit more to say, are there opportunities to make it run even better? So we started looking at memory optimization, cache optimization, vectorization, threading, and said, yeah, there's a lot of opportunities there. And one of my collaborators, Arch Robison, will be speaking later this week. He was instrumental in some of the early vectorization work. And our colleagues in Intel Labs started doing some work in code transformations, threading, and optimization. And a lot of this work, with collaboration of the broader Julia community, eventually has resulted in the @threads package, which I was just told was released in the 1.3 alpha update, alpha release a few seconds ago. So I encourage you all to look at this. It's been a long collaborative effort with Intel's help and the broader community's engagement, but I think it will provide a dramatic enhancement to the language in the package. And I just wanted to bring up one slide. I don't have equations or codes, so I'm sorry for that, but I do have a chart. And this chart sort of motivates why we've been focused on threading. It's sort of a normalized performance chart over time of where does the performance in your computer come from? Does it come from the micro-optimizations we're doing to the microprocessor itself? That's the red line at the bottom. Does it come from the vectorization? Well, that's the little gray line above the red line. Or does it come from threading? And that's the orange line up there. And you can see each one contributes a little bit. Threading contributes quite a bit more. But it's the combination of all of them together that gives the ultimate performance our platforms can achieve if they're used correctly. So if you use the memory system correctly, if you use the vectorization capability correctly, if you use the threading correctly, you can be running 100 times faster than if you don't. So that's the main reason we've been focused on some of these optimizations is there's so much latent power sitting in your process, in your computers, that many people can't tap into without some of these changes. So to close with this, I do want to shout out to a couple of the Intel contributors. Kieran and Anton have stuck this out over the past few years and helped work with the community to make this a reality with this current release. And I know there's some legal things here and there that I need to sort of go through, but that's it. So thank you very much.